planet Earth, peaceful today, has suffered its share of collisions, massive eruptions, and mass extinctions. But most earthly disasters pale in comparison with the apocalyptic traumas that befell our siblings in the solar system. The solar system was born in a maelstrom as billions of rocky boulders collided to form the planets we know today.
The birth of the solar system was full of violence. There were all sorts of planetesimals and protoplanets colliding with one another or going close past one another and ejecting each other or sending each other down toward the sun. So, you know, only a few planets survived.
The early solar system was very much like a cosmic pinball machine. You had lots of impacts, lots of collisions taking place, destroying planets, forming planets, breaking apart planets, creating everything that we see today. But long ago, it would not be the type of place that we'd want to live.
As the surviving planets took shape, the violence only intensified. First and earliest on our countdown of the 10 worst planetary cataclysms, the Mercury Mantle disaster. Mercury, the closest planet to our sun, is also the runt of the solar system. Now, scientists think the puniest planet was dealt one of nature's mightiest blows.
Mercury is a mystery to scientists. The iron core inside Mercury is about 40% of the volume of the planet. Whereas on Earth, for example, the core is only about 20% of the Earth's total volume, even though Earth is about 3 times larger than Mercury.
Mercury is a bit of a conundrum in planetary science. It's like the solar system's big ball bearing sitting out there. It's almost like a pure piece of steel. How did that little planet get so dense?
One theory holds that a planetary collision was the culprit. But how could an impact make a planet dense? By envisioning Mercury's cosmic attacker as a cannonball, we can help reimagine what happened.
Let's fire cannonballs from this American Revolution cannon at a bowling ball covered with plaster 40 yards away. Now, that bowling ball covered with plaster represents the early Mercury, where the plaster is the mantle and crust. Now, Gary Harper, our weapons expert, is going to fire this cannon for us. Gary, how do we do this?
Well, fairly simple. We use the appropriate powder charge, insert it into the bore, seat it.
Yeah.
We take our cannonball, we'll set that in, start it, we'll set that on top of the powder.
How fast is this thing going to go?
Should be going about 300 feet per second.
Wow, that's about 200 miles an hour. Should do some real damage.
Now, how about some hearing protection, Alec?
Right, and my glasses here, right?
And your glasses.
Okay.
Now all we have left to do is prime it, and we're ready to fire.
All right, let's fire this cannon.
Okay, fire on the
All right.
hole.
Oh, yeah! It hit! You blasted it! High five! Woohoo!
We gotta go take a look at that.
Yeah, let's go take a look.
Okay. Wow, there's stuff all over the place
Oh,
here.
yeah, the plaster has been knocked off. Look at that.
This is exactly how scientists think Mercury's crust was blown away, leaving the remaining planet an iron core.
So this nicely explains how dense Mercury is. It has this big iron core because the rest of this stuff was largely stripped away by the collision. So good job aiming the cannon at this bowling ball.
The celestial crack-up would have ejected Mercury's mantle into the sun and flung it as far as Jupiter. The wreckage rained down for up to 4 million years.
The debris went throughout the solar system and could even have landed on planets. In fact, there are some estimates that up to 16 million billion tons of material from Mercury landed on Earth.
But proponents of the cosmic hit-and-run theory face a forensic dilemma. If the collision happened, why didn't it leave a visible scar on the surface?
Other ideas for the formation of Mercury's large core involve the local environment of Mercury being so hot due to fluctuations in the solar output that the entire planet actually vaporized. The rocky mantle actually became rock vapor. And then the solar wind blew that rock vapor away out into space. So that's another possible explanation for why the core survived, because it was made of metal and didn't suffer quite the same vaporization as the outer rocky shell did.
NASA's Messenger spacecraft is currently orbiting Mercury, hoping to unlock the mysteries of its turbulent past. But it wasn't just the innermost planet that took a beating. Today, Saturn's spectacular rings rotate in calm serenity. But they owe their beauty to a makeover of the most violent kind over 4 billion years ago.